Okay. Om Sahana Bhavatu Sahanau Bhunaktu Sahaviryam Karavavahai Tejasvinavadhitamastu ma vidvashavahai. Om Shanti Shanti Shanti. Okay. Okay. Thanks everyone for joining on time. Welcome to the second session in Nakshatra Vidya. With that, I will hand over to Sri Gurupriya Chaitanya ji.
The domain of Nakshatra Vidya, we always begin with an invocation from one among our ancient Nakshatra Vidya texts. So we'll begin with He Vishnu Nihitam Kritsnam Jagat Tvayyeva Garane Jyotisham Jyotishe Tasmai Namo Narayanayate. The last class, we paused at somewhere here, reflecting about something called the Savana Dina and then the Arksha Dina, that is the civil day, and the sidereal day. Arksha Dina is called the sidereal day technically in modern astronomy. It's the actual time that it takes for Earth to complete a revolution. But when we talk about 24 hours, with respect to our experience as the observer on Earth, we wish the sun must come back to the same either dawn position, noon position, any position can be a reference point. And we need sun to come back to that same place to say, hey, one day has passed. So if we take noon to be the reference, then it takes about 24 hours for sun to come back to the noon back again. However, it's not the rotational period of Earth. We saw this, and we saw that as the Earth moves a little along the orbital, it takes a little more time for the sun to come to the same point as we observed yesterday on the sky. So that means, the same zenith distance. Then in such a case, then it means that we are going to have a slightly longer period than the actual rotational motion, and that's how this 24 hours was born. It was earlier called 60 ghatis in the Indian system. We look at time and panchanga a little later. We had this discussion last time. Now, this is something that we must be able to understand and observe. There are actually three different frameworks of reference when it comes to looking at the stars, looking at the sky. On the Earth, to position ourselves, we have the latitude and longitude. Similarly, to position any object in the hemisphere, any celestial object in the hemisphere, we've got to use multiple ways to understand their position. One such set of indices like x comma y is the zenith and azimuth. The zenith distance and azimuth. What does that mean? Let us say you observe a celestial object here. From our zenith, if you draw a meridian that passes through this object all the way to the horizon, then this distance is the zenith distance from the zenith to this point. That's called the zenith distance. Arkha Madhya Vivarana, it is called. Similarly, there is this right ascension. We will come to that a little later. Then azimuth is also there. If this was my east, then this would be my north, and this would be my south, and that point, that cardinal point there would be my west. Now, from the meridian that goes from my zenith through the pole star, if my pole star is here, I'm probably in that latitude. We saw that already, right? What it goes through my pole star, the meridian that goes through my pole star, the celestial meridian, and then it will meet the horizon at some point, which is my cardinal north. From the cardinal north, what's the arc distance, right? So the angular distance. This is called the azimuth. Knowing the azimuth and the zenith distance, we have certain like an XY coordinate. This coordinate system helps us position a particular star. However, this is very, very observer centric because this dome changes quite a bit for everyone, right? So zenith and azimuth calculations are very useful in the ancient Indian traditions until and unless you are doing the same observations from the same point every day and you're trying to observe some phenomena. When you want to do, observer independent, that is location independent observations, then you might have to use some other way of reference. We will see that a little later today. However, this visible dome, understand it to be now, to form the horizon and the zenith for us, which forms a frame of reference. Why is this important? All that will come a little later. However, this is a frame of reference. This is okay for all. I'll move ahead. We will again revisit some among these. We will look at the stellarium, we'll look at certain stars, we'll try to understand them. Now, as I said, the polar star or the Dhruva Nakshatra holds a special place in our, be it in our Itihasas. The story of Dhruva is very, very captivating in Bhagavata Purana and talked of great bhakti and devotion by a very young child. And, all he was wanting was for a sthana on his father's lap. And he got the ultimate sthana of a Dhruva Nakshatra over time, the blessings of Mahavatar Shri Vishnu Bhagavan. And what we also see is that this plays a very significant role. The Dhruva Nakshatra plays a very significant role as it is very close to the axis of our rotation. It's not exactly falling on our axis of rotation. It's very, very close to the axis of rotation. Why? We will see. Currently, it is not exactly on the axis of our rotation. Why? We will see all that again a little later. Okay. So this ancient Indian astronomers understood that the angle between the pole star and the observer's horizon could determine one's latitude. This knowledge was crucial for navigation, especially for sea voyages in ancient India. And the rotationary motion, we started exploring the rotation of the earth and its various effects as we see them, right? So this rotationary motion, right, which determines Dig Desha Kala, for us to understand Dig Desha Kala Nirnaya, by deed, sort of re-engineering what we observe, and sort of deciphering from that, right? Towards that, ancient Indian astronomers put in a lot of effort, right? So this rotationary period determines our equation of time on Earth. Equation of time is a very technical astronomical term, and it, to broadly understand a few things, we must understand this conversion, okay? So that the time difference on Earth and all that is right now though well understood. This again belongs to ancient Indian calculations, right? How are we converting time zones? This is called Deshantara Samskara that we do in Indian Nakshatra Vidya traditions. This 360 degrees, right, for this rotation to get completed, it takes about 24 hours, right? Which means to complete 1 degree, it takes about 4 minutes. And to complete 1 arc minute, it takes about 4 seconds. For Earth to complete 1 arc minute in its rotationary motion takes about 4 seconds. And 1 arc second for the Earth to complete, this takes about 1/15th of the time second, right? So thereby, if you are 1 degree away longitudinally on Earth, you will have a time difference of about 4 minutes. If you invert that, if you look at 1 hour, right? 1 hour, which is 60 minutes, you got to multiply both sides by 15, right? So for 60 minutes, you will see a longitudinal difference of 15 degrees, right? So if there is a time difference of 1 hour between two places, then their longitudinal difference is about 15 degrees. And if there is 1 minute time difference between two places, it is about 15 arc minutes. And if there is 1 second difference between two places, then about 15 arc seconds is the angular measure of the distance covered on the longitudinally along the earth, surface of the earth. So this kind of relationship we knew very, very well, right? We knew that the latitude does not affect the time of the day. However, the time is determined by the longitude, but latitude plays a significant role with respect to the length of the day. Okay, particularly as one moves towards the equator, away from the equator towards the poles, a great, wonderful function was earlier found with respect to function of the length of the day. In fact, right now, as I was saying in the last session, right now I was there to publish some research to work on some publication with respect to a certain equation given in Vedanga Jyotisha with respect to calculating the duration of the day and night in any location. Vedanga Jyotisha, talking about, which is we have already seen, right? The Vedanga Jyotisha is more than at least as old as 1600 BCE, right? And it is at least as old as that. It's based very closely, to the Rig Veda. If you don't even prescribe to these modern historians and their timings, we know that it's very, very ancient time. Since a very ancient time, we have been trying to find out and find approximations to calculate the duration of the day and night. At the equator, the day and night are nearly equal throughout the year, right? Each roughly lasts about 12 hours. As we move towards higher and higher latitudes, the difference in the length between the day and night becomes more pronounced, right? Especially during different seasons. Why? Once we look at the revolution of the earth and what are all the observer centric effects that it has when we look at the sky, we'll be able to appreciate that. For example, the Ujjaini longitude right now is 75 degree 47 minutes east, right? And if the time in Ujjain is 6:30 a.m., now let us say we want to find the time at New York, okay? This 74 degree west, right? Now we know that to the prime meridian, this is 75 this side and that is 74 the other side. So when you put them together, it's about 149 degrees and 47 minutes apart, right? So, and we saw each degree contributes to 4 minutes and each arc second contributes to 4 seconds. Thereby, you will be able to do the Desha Antara Samskara, it is called, right? So this is very, very important, especially in Panchanga makers. If you see, a Panchanga is valid to a local mean time, LMT. So every important town and city in Bharat has Panchanga makers, and they all make it specific to that local mean time. So we convert these 149 degrees into 4 minutes per degree and 47 into 4 seconds, right? We get 596 minutes and 3.313 minutes basically. So put together, it is 599.13, which is 9 hours and 59 minutes away. So all these we were very, very, very conversant in earlier. Similarly, we subtract this from Ujjaini time, and this tells what the current time of the previous day is happening in New York. Yes, please.
So, so all this knowledge and being conversant with all these calculations, what time frame do you think this must have been in? What era? This was, much after the Vedas, or this is like, I mean, modern dating is different, but I'm just wondering, in terms of chronology, how ancient or old is this?
Okay. So, the core concepts that I'm talking about are as old as the Vedanga Jyotisha. Okay. But exactness in calculation has continued to improve over time. From the Vedanga Jyotisha, there was an improvement in the Siddhanta era, which we do not know when it was, but thankfully Varaha Mihra has sort of tried to capture 5 of the Pancha Siddhantas. He's saying that 18 schools of thoughts, 18 perfect school of thoughts existed before him. And by that time, when he could collect the knowledge, he could collect only 5 of them. So Pancha Siddhantika that he wrote in the 5th century CE, right? We see that he has written around the 5th century CE. Maybe I can go back to it and also show this to you. So this is on 1400 BCE is Vedanga Jyotisha, right? And over time, the entire concept of latitude, longitude, all that has existed, from that time without calling it this exactly. But we can see that by the time of Vararuchi, the Chandra Vakyas that we're talking about, this is in Katapayadi, and worldly wisdom encoded the celestial longitudes of moon. So the longitudes of moon, correct to arc minutes, we have the celestial longitude of moon recorded in 4th century CE by Vararuchi. So with respect to Jyotisha, we were really, really ahead of our time. But what Aryabhatta times onwards, it helped us do trigonometry, right? Aryabhatta phenomenally brought out trigonometry, which we saw a glimpse of it in our math class, right? So owing to many trigonometrical functions and better understanding of some among the non-linear motions rather than only empirical understanding, the trigonometrical functions allowed us to better define all cyclical phenomena very, very well. Thereby, we see a huge accuracy from Aryabhatta's time. See, but Aryabhatta is also very clear that a good amount of knowledge that he is trying to compress in his Aryabhatiya has been there. Okay. However, always people strive to better the parameters, localize the parameters, make calculations easier, make calculations more accurate. Why? The parameters that we are talking about vastly differ in astronomy. For example, I'll come back to you. Somebody has raised the hand. I'll just come back to you.
Sure.
What has happened is, for example, the same orbital path that we took last year, we are not taking right now. Not because we are a swirl, we are going into space. Actually, a good amount of the space is encapsulated and incubated. But the very orbital, the nutations that the Earth is going through is not the same. The distance between the Earth and the Moon is not the same. The distance between the Earth and the Sun is not the same. They are all constantly changing, affecting various parameters in the observations. Even now, all the important del U studies, that is the change in the spin of the Earth. A lot of studies are retrospectively trying to understand how the spin of the Earth and its movement has changed over time. For example, now the spin is slowing down in microseconds, right? Year by year, it's slowing down in microseconds, but there will be a variation. If you look at a 100-year window, there will be a plus 46 microseconds, there'll be a minus 9 microseconds, there'll be plus 9. So it's going on. The more you observe, the more data you collect, the more and more accurate you can become. So the foundational frameworks were very much present from the Vedanga Jyotisha time. The very fact that the time varies from sthana to sthana, the length of the duration of the day varies from sthana to sthana. One based on Kshitija, the other based on Shara. Both of them were well known, from the times of Vedanga Jyotisha in itself. So Vedanga Jyotisha currently has an equation which we are trying to unearth and publish and try understanding it through various means to sort of determine the geographic location of the Vedanga Jyotisha where these equations are best fit for current, given the current computations, given the current computational astronomy that we can do, backtracking to different times, looking at different geographies. We have been looking at which area best suits some among the Vedanga Jyotisha calculations, and our conclusion is that it's along the Gangetic plains, where it best suits many of the observations that have been
Observation.
recorded at that point in time.
The
So
primary motivation for all these advancements and refinements over time was to identify appropriate muhurtas and things like that for different activities.
certainly, even if you look at a wedding, you have to point to the today they just blindly point at Arundhati where we do not know. But earlier, you had to point to Vasishtha Arundhati. It can be down, it can be anywhere. You need to know to point it. So all our socio-spiritual circumstances, our Vedic way of life, our Sanatana Dharma demands a certain alignment to the overall Prakriti.
Prakriti.
And there we have to become very good at, because a good Jyotishi is someone who says, who can do good Kala Nirnaya. And when he does Kala Nirnaya, the phenomenon must happen. We must know when to observe the eclipse. We must know the time at which to do a particular Shardam, a Tithi, and it should correlate with your observation. So thereby, it's much like machine learning, right? Over time, you had to collect a lot of empirical data and create fitment, and then they created phenomenal equations and fitments, and especially once the trigonometric times all came, their models were brilliant. If we go into it, it's going to take us a lot of trigonometry, but you can take it from me. We can definitely share a few papers for those who are a lot of math whiz here. You can, sort of understand how the epicyclic models and the different planetary models were continuously updated. Similarly, as I said, there were different kinds of texts, right? One is the, what we talk about is the Vedic, adjacent texts, which are the Vedanga texts, which all this comes under. Then post that, there are different kinds of texts. These are all lookup tables, right? Which are all koshtas, like Chandravakyas. The one that I'm researching on Mallari's, ecliptic calculations, Parvatvaya Sadhana, they're all koshtas, which are all tables, like Clark's tables. These are all tables. Then we have the Siddhanta text, then the Tantra text, the Karana text, and based on that, Panchanga derivatives are there. So this is how we have been going. The Siddhanta texts deal with very large periods. The Tantra texts deal with a certain localization within a Mahayuga. The cyclic periodicities, right? The Siddhanta texts try to understand when all Yugantaras will happen, when all Kalpantaras will happen, when all Ujjantiti Yugaha, when all the planetary alignments would happen at different points in time, Grahachara and Nibandha, and so on. Many things they try to calculate with respect to, when these certain cyclic alignments would happen. The Tantra text will begin with a particular cyclic alignment and an observation of the longitudinal portions at that point in time. Since this much time has passed, these knowing their rotational velocities, revolutionary velocities, you will be able to understand where we are exactly based on that location at some point in time we were. That is how Tantra texts work. Karana texts work on a very short period of time, 300 to 400 period of time. So that's your framework of reference. On that day, these were the accurate observations of these celestial objects. This much time has passed since then. Where would they exactly be right now? Which allows for more local accuracy. Then comes the Panchanga text. From the Karana text, be it Vakya Karanas or the Drik Karanas, you would collect from these Karanas, you would have a certain set of Vakyas, mainly Koshtas, like the Chandra Vakyas and so on. So those Koshtas will be used to create the Panchanga by Panchanga makers.
Yeah, thank you, Ji. Yeah.
Question about the regional or local Panchanga, like the experts who actually manage that, around what time period or how they've been able to sustain and, kind of keep that tradition going for all these years, So I'm just curious, like, this is a long period of time you're giving from, and like, yeah, I agree. I can see the, I guess, constant changes there all the time. The sustainability is another whole other science by in itself, and the process of learning and then retaining it and then passing to the next generation. So I'm just wondering when that would have actually been embedded in the society, and then still be scattered in every single area. And then compare this to another civilization, maybe, if something even exists like that.
Yeah. So we had huge civic projects, like that, to collect data. It's been a very important. There have been daivagnyas. There have been certain kulas. When you entrust this with a certain kulas, lives after generations are basically committed to it. For example, there were great Jyotishis from where we are, the ashram, where everybody has deserted. So what has happened in the 1940s? Many of these people, from where we have, the Kaniyur village and the nearby Kodumam village that we are in. Kodumam was known for its Jyotishis at some point in time. In the 1920s and 40s, there was a mass exodus from here to Coimbatore, to a place called Ramnagar, which is very popular in Coimbatore. It was completely populated by all these families here at Kodumam. Now there are 2 houses left in the Agrahara and about 2 families there. And all those people who went to Ramnagar, when I try to trace them, when I try to find them, they've all gone to, most of them have gone to, in fact, there is one state that they've gone to, California. And they have even, so I'm not able to trace many of the Jyotishi families which are here. So there have been mass exodus, but until and unless and until the thought of Artha Pradhana came into this Bharata Desha, till then there was Tyaga and Tapas. Even now, abundant Tyaga and Tapasya throughout the world, throughout Bharat, and before that as well. So all the Panchanga makers will gather for a Sadas. Even now it is happening at the Kanji Mat. And the head of the current Panchanga makers of the Kanji Mat is in fact my yesteryear school senior, and even now we are in good touch. We work on various projects together as Anadi Foundation and there, with the Shankara Mat there. So he has been striving to bring about various corrections. Earlier, it used to be a 300-400 years, a mass of this would happen, where a lot of updates they will do. They will update the data tables. They will have to update, because even now, right, when the neuronal weights keep changing based on people, how they observe, how they do things and so on, right? Even in machine learning and neural networks. Similarly, you've got to update these parameters. Unless and until you update certain axial shifts, update various parameters. Why? I will explain what parameters in a little while. If you go further ahead, I'll be able to show you the kind of mind-blowing parameters that they've been able to observe and then try to update over time. The Drik Panchangas have just a couple of centuries back updated it. In the 15th and 16th and 17th centuries, they have been updated continuously in the Kerala school, and thereby the Drik Panchanga, they say, is one of the most accurate Panchangas when it comes to current day observations. So the Madhva traditions, they have their own Panchangas. The Raghavendra traditions there, they've all tried to, every mutt has tried to create a Vijnana section within them, and they have tried to actively create and enable various scholars to work extensively on this till today. All the mutts are working, striving, whoever is doing Veda Rakshana are the people who are striving to protect this knowledge system extensively. Even now many of the Panchanga makers have woken up to the updates that are required. Might be the years to come, we will see, especially, the grand projects are in play, but you'll have to work with a whole host of, working with 5-10 people in itself is very tough, but you'll have to work with a whole host of Panchanga makers around Bharat with the diversity. In 1950s, 60s, KC Chakrabarti, a few others took up a project to consolidate all Panchangas, only to have their mind blown further and further, understanding that would never, such a convergence would never happen. Right. So if you try to create a Gurukula board of education and then run it like CBSE and expect everyone to do the same standards, it's going to become crazy, right? So like that, he found it really, really hard. However, the Indian ephemeris, be it the ISRO, be everyone, reads the Panchanga. There are beautiful classical Indian ephemerises which take into account some of the Panchanga calculations as well. But many of the modern tools that you see today are all using data from the West based on actual observial calculations. That is also not bad, right? Nothing wrong. But many of the computational astrology and astronomy that you see today are all based on many of the Jean Meus and many of their astronomical algorithms that are currently present.
Dhanyawadaji. It's just I'm just trying to relate, our current, whatever you call modern way of thinking of institutional or organizational change management,
Yeah.
and like all these jargons that we put in on project management, technology, all this, languages that we use for writing, everything, right?
Yeah.
To that of how ancient it is. I'm trying to correlate our current life and our challenges to time and space for such an old traditional way of things. Was it like few people that actually managed, or institutional, like
Much, mainly the
organization
much.
parts? Yeah,
Yeah.
and looks like it's still in the, it's still fairly well
Very,
managed.
very active. Very
We have
active.
no, I have no idea like how much
The
actually.
next class, I will show you the Central Sanskrit University's
Thank you.
published Panchanga. It will be my arm's length, half arm's length. I'll show it to you in the next class.
Dhanyawad.
Namaste, Gurupriya Chaitanya ji.
Namaste.
So usually, right now, how we look at the calendar, right? Like, whenever we have any auspicious things, like, marriage or
Yeah.
childbirth, like, or like, if you want to do, when is the next Ram Navami or Krishna Jayanti, like, so
Mm.
then only we open the Panchanga and see it, like, when exactly it is happening.
Mhm.
Why we are, like, not adopting those things for everything, like, why we used to follow that Indian, or like, why we are not preferring to use the Georgian calendar versus our Indian Panchanga for everything.
Yeah.
Is it
So
easy?
good amount of India still relies on it, G. Actually, a vast amount of the population, say for example, Kumbh Mela, right? Any of the Ramanavami, everything, that we celebrate is actually synced. We are all synced calendarically, with respect to the Panchanga only. It's just that we have to wake up to it. And we are having a section on Panchanga. I too, when I started studying about the Panchanga, I felt it's become very archaic. The more we study the science behind it, it's mind blowing. And you see that a good, because of the temples, because of Sanatana Dharma and Sadhu Sangha, it is still maintained a good amount of Bharat. I just said, and even in the last class, that because the marriages are all fixed based on our Panchanga, the consumer markets, the global markets are awakening to understanding and including this into their case studies as well, like Kishore Biani and so on as well. It's very much, very actively part of the Bharatiya fabric. Though what we do not know is, we do not know to appreciate the calculations behind it or the science behind it, which this course will allow us to do. But very much around Bharat, the Panchanga is rigorously followed. Especially if you look at many different states, all rural places, wherever there is a temple, you will have enough knowledge about Panchanga, knowing, and being in Bharat, you will know your nakshatra, you will know your, Janma Rashi, what they are, we will see, the mathematics behind it in this course, we will continue to see.
Oh, one follow-up question on top of that. So we have a lot of confusion when some festivals, right? It comes under someone will say, like, it is on 24th of this
Correct.
one, and like, when it is
So
someone.
not really confusion, I would call it. I would call it diversity. What they are, there is a session on Panchanga. We will decode
Okay.
the Panchanga together. Yeah.
Thank you.
Yes. Yes, Dinesh.
नमस्ते।
Namaste.
आपने बताया कि सभी कोयम्बतूर चले गए, फिर कोयम्बतूर से कैलिफोर्निया चले गए। ये तो देश का दुर्भाग्य है। लेकिन आपको क्या लगा, क्या हुआ कि ऐसे लोग अभी देश छोड़ के जा रहे हैं पैसों के लिए, तो और क्या कर सकते हैं?
So, the one is we can philosophize about it. The other thing is Kala Niyati, I would call it, right? See, once at some point in time, the Vedas were fully submerged. Unless until Varaha Avatara could come and revive it, right? The knowledge itself can become submerged. But beauty is, Dinesh ji, still people are keeping it alive. And you are all connected to Bharat still here, attending these sessions. We will revive it, Ji. We will reverse this. We will ensure that the Gurukula systems again emerge. We will work together to somehow make this. But you are right. It is unfortunate that this has happened to Bharat. But it is a blip in our large, beautiful history. continuing Sanatana Dharma, we will bounce back, I'm sure.
अभी इसको ना हो इसके लिए क्या कर सकते हैं?
We'll study, Ji. We'll study, preserve, protect. At the end of this course, Ji, we will again discuss this topic. You can go and then share about this to 5 more people at least. Help read the Panchanga with everyone. Help read the Kunli and then try to understand the scientific geospatial timestamp behind it. This course must be the answer to your question, I hope, Ji.
I wanted to add our most Indians started learning yoga only when Westerners adopted it. So
Now we've got to have Apple Watch now become Panchanga ready, I hope.
the easiest way to get our culture adopted is to have the Westerners adopted through our own people in their society. That's when our own people will have more trust and belief and understanding of how
What
important.
we feel is the accessibility. What with the West and the yoga and what that talks about is a consumeristic accessibility to yoga. The West sort of brought it out, right? It helped package, it helped present, it helped people consume it as one unit of wellness for myself, for example. Similarly, we'll have to create more accessibility to our content. We've got to decode our content and present it in a modern light. Build apps, build various things. I'm sure the knowledge, systems of India incubator here might pave a path for doing such wonderful initiatives.
But all this while making sure that we get the credit for it, because that always is.
Yeah. That we must be in Jagrata Avastha. We must be awake. We must be very alert. We should work and collaborate, not by labels, but with very sincere, very earnest people. Through collaboration is only will bring this more forward. But our collaboration must not be naive. Well-meaning panditas, have been very naive and very genuine and very trusting, and their trust has been broken by many of the Western research collaborators. That I hope we have awakened to it. Many, people have awakened to it. Thereby, let us try to see how we can stay very alert and try to protect as much as possible. See, now even when we spoke of math and all that, we pretty much think all of math, right, is Western. All of science is Eurocentric for us. The very number that we have, the very calculation that we do, everything has Indian origin. Every single whatever you thought of Western method and non-Vedic method, everything is Indian method, right? So that's how knowledge has been, spreading from here. We will reverse the GST. It depends on how fast we can become the Vishwa Guru. Towards that, we should build strength. A lot of work is needed. We will work. We will work towards it.
Sorry, one more question, Ji. In India, I've seen that largely we celebrate 2 New Years. One around March time frame and one around April time frame. I'm sure
one is the lunar calendar, another is the solar calendar. We might have to do a little more to understand.
Okay, yeah. At some point, if you can help understand this, these two, families of New Years, I think that will be helpful. Yeah.
Certainly. I have complete slide packs on them to understand our diversity, understand the Dharma Shastras. So, to give a gist of answer to all your questions in terms of with respect to, our astronomical calculations are foundational. There are different schools there, Vakya school, Drik school. Their calculations can vary. Different schools, once they have calculated, each subsect's Dharma Shastras are different. So, based on the Dharma Shastras injunction, a particular vrata will be followed by someone, particular vrata will be followed by, for example, people want to end Ekadashi in fasting. People want to begin Ekadashi in fasting. These are all, injunctions that different groups have taken upon themselves. So then your day of fasting will be different from another person's day of fasting. Right? Then some would want the tithi to be prevalent during the sunrise. Then I will celebrate such an event. then if not, you might not celebrate. So there are different schools, different Dharma Shastra schools that dictate different things, and we have so much diversity in our calendar. We're only beginning to unravel this. If you see the Adhika Masa and the kind of things that happen in the Indian calendar, mind-blowing things happen. Let us see some among the facets. For the moment, I will move ahead. So we saw the rotation of the earth and the kind of, in the Dik Desha Kala Nirnaya, the kind of effects that it has. And we saw some glimpses about how did we do Dik Desha Kala Nirnaya, how is the observation-centric, frameworks of Bharat were very robust, because we looked at some of this and we have recorded this since a very long time. We have understood our motion. So every time the problem of we didn't have heliocentricity is gone, because we are carefully, with an observer-centric eye, we are looking at all the patterns and cyclic nature, and our calendar is not arithmetic, it's completely astronomical in nature, because we rely on celestial patterns, and we have been good at decoding that only by looking at the sky. So now our sky watches become very, very meaningful. Like we last saw, just looking at the pole star, just looking at the moment of the sunrise, how far does it come from the zenith, etc. All that makes our location evident to us. So this geocentric versus heliocentric model, right? If you see, we know clearly, right? This is the very simplistic representation of it. However, in the geocentric, the Earth was modeled to be at the center with all celestial bodies revolving. This model was prevalent in India and elsewhere as well, right? Even Copernicus, who proposed the heliocentric, he himself backtracked and he said, hey, this can't happen, right? So the model is now known not to be true. It served as a means to study the motion of celestial bodies and calculate their periodicities very accurately. For example, it's a model, right? The model of the atom is forever evolving. Right? We have studied the Thomson's watermelon model. We thought the atom was like a watermelon, right? With protons suspended in between. It's a big ball, and then the electric charge around it, right? So we thought about that like that. Then we thought about orbitals, right? We in fact thought the atom to be something like this. It's a Bohr's model, which is not true as well, right? And then we thought it to be in a three-dimensional way. Now what they say is that the electron orbital is a probabilistic cloud. The atom looks, after all, like a cloud, right? So the charged particles can be at different places. So these kind of understanding of our models help work with our understanding, and making things more accurate. But at the same time, it doesn't mean it doesn't work, right? Our earlier understanding of the atom allowed us to even build the atom bomb, right? Even if it was in a nascent stage, or to build atomic energy research centers. Right? Similarly, the geocentric model works very soundly well in an observer-centric view. Right? Even now, right, when you go to Mars and when you go to various places, you need to have an observer-centric view without which you cannot communicate various things. Right? So, but much later, you must see, before Copernicus, before any of these Western counterparts, right, arriving at some among the heliocentricity, we should credit Nilakanta Somayaji for arriving at this model in 1500 CE. See, Nilakanta Somayaji, he proposed this model. What did he say? See, the sun revolves around the earth. But these other celestial objects have a revolutionary period around the sun. They're centered around the sun. So their orbital radius, which is always changing, right, is based with the sun as its center, not earth as its center. Right? So this was well derived through careful calculations of retrograde motion, various other things by Nilakanta Somayaji. His planetary model is path-breaking, very, very revolutionary, and allowed us to make very accurate, calculations with respect to planetary positions. Though this geocentric is not known not to be true, it serves it serves as a means to study the motion of the celestial bodies and calculate their periodicities. Well, I've written, well is an understatement, very accurately actually. So Copernicus is credited with suggesting the heliocentric model, which was adopted by Galileo at the end of 16th century. But it is good to know that the heliocentric model, in order to appreciate various phenomena, that we are going to see in the observer-centric world as well. So both models we must be good and knowing about them. So we know that the moon is spinning around, revolving around the earth, and the earth is revolving around the sun. We know all this is happening in the anti-clockwise direction. And what happens? This earth completes, this orbit around the sun in about 365.2422 mean solar days, which is known as a tropical year technically in astronomy. Dividing this 360-degree orbit by this periodicity, we get about 0.986 degrees, right? Each day on a mean time. There are times when it speeds up, when it slows down. The mean angular distance covered by Earth around the sun on its orbit is about 0.986 degrees per day. This might not seem like much, but over the course of a year, these small daily movements add up to a complete orbit around the sun. This is why we see a gradual change in the position of the sun in the sky over the course of the year, leading to the progression of the seasons. Okay. So there are some beautiful things we are going to see in this thing. Now we know that the Earth's orbit around the sun is not a perfect circle, but it's rather an ellipse. But it's not like the ellipse that we imagine it to be, right? When we draw an ellipse around the orbit, we draw it like this, right? We draw it like it just fell flat, right? But it's actually, its eccentricity is very, very small. It's only 0.0167, where 0 would be a perfect circle and 1 would be a straight line, right? At the perihelion, where it's closest to the sun, it's about 14.7 crore kilometers away, or 91 million miles. The farthest is aphelion, which is 15.2 crore or 94.5 miles away from the sun. This elliptic nature of the Earth's orbit contributes to slight variations in the length of the season and the intensity of the sunlight received, but this is not the primary cause of the season. This is the primary cause for a few things in our calendar, especially when do we slow down, when do we not slow down, etc. Okay. Similarly, there is a tilt of the Earth, and this axial tilt today is about 23.5 degrees. It varies from 22.1 to 24.5. Aryabhatta has noted it to be 24 degrees in his period. Okay. So this axial tilt or obliquity of the Earth, this tilt in itself varies. What is this axial tilt with respect to the plane of our revolution? What is the tilt of our axis of rotation? This is about now 23.5 degrees, right? And it has been varying constantly, right? This, as I said, Indian astronomical texts estimate this to be 24 degrees. This axial tilt is critically important and influences the intensity of the sunlight we receive, at different parts of the Earth throughout the year, thereby causing the seasons, right? If we must, if I can share a different page. So here we see the sun in the center, right? And we see Earth, and we see the Earth to have a slight tilt, right? The red line here is the equator. This is the Tropic of Cancer, and this is the Tropic of Capricorn. Why are they named that way? We will know in some time after we understand the Rashi chakras and so on. Then this is the Arctic Circle, and below that is the Antarctic Circle, which is not visible right now. This view, this view that we are going to see is where should I place this observer on Earth, which latitude. At different latitudes, I will observe things very differently, right? So I'm going to place myself to where I am closely now. Okay, let's go to Austin a little later. But now let's say I'm at 10 degree north latitude. Okay. This is the view. This is my angle of inclination of the sun's rays. As the sun rises up, it might fall this way. Okay. It can have a northward run or it can have a southward run. We will see about them. I have to reload it. Stuck.
Ruffle is the name of the app you're using, G?
This is University of Nebraska Lincoln's astronomy. Astro UNL by University of Nebraska Lincoln. This is a local copy of it. It's not loading. Just a moment. In the meantime, let us go to Stellarium.
आपने वो फास्टिंग के लिए बोला था, तो वो फास्टिंग के पीछे का साइंस क्या है?
Okay. Did we finish our Ayurveda course, G? Yet? We are yet
No.
to start. Shrikantji, as part of KSI, did we already complete the Ayurveda course? So in Dinacharya, Ritucharya, Ji, there are different bodily cycles. Based on that, we do, various aspects with respect to fasting. I'll come back to it, Ji. Can you all see my screen now?
Yes,
Sorry,
Ji.
can you see my screen? Okay.
Yes.
So now, in the same date time, I'm going to 7:20, let us say. And let me pause the time. I'm currently in Parani and I'm watching the sun at 7:20 a.m. today. Now, what I'm going to do is I'm going to slowly shift the day, same 7:20 a.m. From the same point, we are going to observe the sky. Same 7:20 a.m. From the same point of observation, we are going to observe the sky. And that is tomorrow, we are going to observe. Next day, next day, next day. Did you see a small shift in the sun? As I keep jumping days, same 7:20 a.m. Can you see the sun's position shifting? Now the sun seems to apparently have a southward motion. Every day, the sun seems to be shifting, same 7:20 a.m. at a different point in the sky. And this is southward. It goes all the way here, same 7:20 a.m. Now it seems to be having a northward motion. Again in June, there seems to be a southward motion. So we have all heard of this phenomena, right? Uttarayana and Dakshinayana, correct? So we have all heard of this phenomena. And this
Is that in
phenomena
a loop, G? Like, the Uttarayana and Dakshinayana will be makes a loop, like
Yeah.
perfect loop, right?
Mm-hmm. So there are some technical terms for it, for the kind of loop it makes, but it does look like the loop because it's a sine function, right? And we are trying to compress that. Okay. So what happens is, as I go around the sun, as the earth goes around the sun, right? What happens? The axial tilt that we have makes the angular incidence with respect to the sun quite different. Now the axial tilt towards the sun makes the northern hemisphere receive more and more sunlight, right? And somewhere it's on my zenith, it goes here. And what happens slowly after this June period for someone in the northern hemisphere, the tilt, tries to work the other way around, right? The tilt is trying to balance things back, and we reach some point in time, right, where the tilt doesn't matter to us. Here, you can be anywhere on the earth, but the tilt of the earth is not incidental with respect to the angle of incidence from the sun. Then there is, if we continue like this, now the tilt of the earth pushes us away from the sun further and further for someone in the northern hemisphere. the more we are pushed away, right? We reach some point in time when we are the furthest away. The northern hemisphere is furthest away from the sun. So from this period, when we are on the orbital, right, we have reached the southmost. For someone in the northern hemisphere, the sun would have reached the southmost point with respect to, and we saw it come back, right, in the sky. So it will reach that southmost point, and now it will start coming back again. So that was the winter solstice day, and now it's coming back again. And there will be another time in our orbital around the sun where the angular incidence doesn't matter, because the plane of our orbital is different from this, the orbital of the, the tilt of the earth. Right? So here the tilt of the earth is sideways, and it can receive equal amount of, both hemispheres will receive equal amount of sunlight. But when it comes to here, the northern tilt makes, receives more, the northern hemisphere receives more sunlight. Here the southern hemisphere receives more sunlight, thereby causing the seasons, and thereby causing quite a bit of difference for the observer with respect to where the sun is going. So every day, if the sun seems to be having a northward motion, that is called the Uttarayana, that period. That is the period between the, when we are here, the farthest away, right? Sun would have been in the southernmost point. As we gradually go, the sun would have started its northern movement for us as we observe, as an observer on the earth. And when we reach all the way till here, it will reach the northernmost point. This is, the entire period is called Uttarayana. And then slowly when we go around the sun, it will completely go southwards, all the way to the southmost point. Right? From the summer solstice to the winter solstice, it will go to the southmost point when you see it on the along the horizon, which we saw just a moment back. So like this angle of the tilt of the earth and the kind of angular incidence that we have, all these majorly cause the seasons on the earth. Okay, that is why you will see in the Bhagavad Gita, this very tilt of the earth, right, in itself is spinning. You'll see in the Bhagavad Gita that Bhagavan Shri Krishna would say that his favorite month is the Margashirsha month, whereas, and he will say the favorite season there at that point in time was the Vasanta Ritu. At some point in time, Vasanta Ritu would have happened during the Margashirsha month. Now the Sharad Ritu is happening. So like that, this tilt of the earth, is also, like a top spinning. Okay, we'll come to that.
Gurupriya Chaitanya ji, which website is this that shows this?
I'll send you the link, Ji.
Okay.
University of Nebraska Lincoln, Astro UNL.
Okay.
So what happens as we spin around the earth, we reach an autumnal equinox point, then we go to the, this is written with respect to the, here the northern hemisphere tilts the most towards the sun, then here it tilts the most away, right? So we have the winter solstice and it goes on like this. Just from the other angle is short. So we have the Vasanta, Grishma, Varsha, Sharat, Hemanta, Shishira Ritus in the Indian tradition, each lasting of about 2 months each. And this angle of incidence creates different monsoons, different kinds of seasons on Bharatavarsha. So all these, right, there are various characteristics to it. Now it's generally Vasanta Ritu is now generally occurring between March and May. Grishma Ritu is happening between June to August. Varsha Ritu, August to October, but with global warming, all these are changing. All the time the patterns of the weather are quite changing. But the larger pattern remains the same, like this. So this, how will this angle of incidence cause a big change with respect to our temperature? It's, with respect to our seasons. You see, this is a classic example in physics, right? When you hit a torchlight directly at the wall, you will see that the light falls with a lot of intensity. If you slightly tilt it, the light intensity disperses, right? So the same, photons are spread over a larger surface area. Here they are intense on the same surface area. So thereby it causes a lot of effective heating. So the length or duration of the day and night also are impacted by this tilt, right? What we see is that above the Arctic Circle, right? Above the Arctic Circle, sun may never set for a short period of time, right? Similarly, we'll see that at that point in time, the Antarctic Circle can be in full night. And especially during the solstice, right? On the day of summer solstice, all regions above the Arctic Circle will not experience even a minute of night. Whereas all regions below the Antarctic Circle will fully experience night. During the other solstitial time, all regions above the Arctic Circle will be fully submerged. And here, this will be there won't be a minute of night even on this. So this dark to white tells you the ratio of day to night in these periods. But why are these called Tropic of Cancer and Capricorn? For that, we should understand the Rashi Chakras a bit. And once we do the Rashi Chakras, then we'll be able to appreciate how this name called Capricorn and Cancer all came. So during these solstitial days, right, and the equinoctial day, so we call the solstitial days as the Uttarayana Punyakala Tithi or the Dakshinayana Punyakala Tithi, and the equinoxes are all called Vishuvat Tithis, right, in the Indian calendrical system. Right, what we see is that during solstices there is no extreme. There is a typo here. During equinoxes, uniform 12-hour day and 12-hour night will be experienced, right? Whereas in solstices it will be quite different, right? It will be drastically different. Okay. This is at the equator. None of this will matter much. With respect to northern hemisphere, summer solstice, long warm days and short nights, the sun takes a high arc across the sky, right? When it comes to summer solstice in northern hemisphere, higher arc. During winter solstice, it will take a lower arc across the sky. And during equinoxes, the day and nights are roughly equal to each other. Similarly, in polar regions, in way higher latitudes, what happens? The sun does not set for an extended period, resulting in the midnight sun. Then in the winter solstice, it becomes the polar night. That is a night for an extended period. Equinoctial days, the days and nights are about equal, but the change is more dramatic, marking the rapid transition from constant light to dark and vice versa. Because on the equinoctial day, they've just started, coming up the horizon or setting down the horizon when you look at the polar regions. Everything is flipped in the southern hemisphere with respect to this, right? So this talks about the tilt of the earth. But the tilt of the earth itself is spinning. We'll come to all that in the next session. Can I go a little into this Khagola and Rashi Chakra? Do we have 5 more minutes? 10 more minutes?
Yes,
okay. 5 more minutes. Okay. So as I said, this earth is rotating, right? And we need to see the celestial bodies, and we need another robust frame of reference for which we already saw this example. When I'm rotating this way, all the objects seem to be rotating the other way, right? So we need a frame of reference. And in the rotating chair example, as I told you last time, when I'm still rotating, I'll be able to still observe that somebody has changed position from one place to another. By looking at the relative frame of reference, the static background, I'll be able to discern. Similarly, we need a frame of reference, and that is called the celestial sphere or Khagola, to understand that the celestial bodies are shifting their location. Otherwise, everything seems to be rising and setting. Have they moved or not? That is a question that we have. To understand that, we need to have a frame of reference, because Mars, Venus, Jupiter, everything is constantly moving. Right? So how do we discern their position? The moon is moving a lot. How do we discern their position? For which we need a frame of reference, and that is called the celestial sphere. And this celestial sphere is an imaginary large sphere of infinite radius with the Earth's center as its center. Okay. And in this infinite radius, the Earth is located at the center, and Khagola is derived from the Sanskrit terms. Kham means this space, and then Gola means the sphere. So as per this Khagola, our own pole, when it's projected onto the Khagola, it becomes the not celestial pole. Our own equator, when it gets projected onto the Khagola, it becomes the celestial equator. Our own plane of orbital around the sun, if you join all the dots, that will become the ecliptic on the celestial sphere. Similarly, the projection of our southern pole becomes the celestial southern pole. So this kind of a ball we imagine. Inside this ball, there are various celestial objects that are moving, and thereby that will help us. This are very far distant stars, like a planetarium. They are not on the same surface, which is very well known. Bhaskaracharya writes in detail about it. But he says that for the purpose of calculations, like a planetarium surface, let us consider the surface as a background, where they are very, very relatively constant. In them, what positions do we go through? In what positions do we see different objects? That was tried to create, and this was the frame of reference. What on earth is this ecliptic? To understand this ecliptic, we must very closely understand what these, what is our path around the sun. Okay, the apparent path of the sun against the background of the stars, it forms the ecliptic or the Bha chakra, or today what we call as the Rashi chakra. Okay, this is very important for understanding the position of the grahas. Okay, we will see this in due time. What happens is, when we go around the sun, we can actually see the background of the sun changing. Okay, we can see the background of the sun changing. And by understanding the constellations that are in the background of the sun, we have created the Rashi chakra that fall here on the celestial sphere. Those are the distant constellations through which apparently the motion we can calculate. For example, when we come to the solar year, how is it calculated? Mesha Rashi to Mesha Rashi. When we enter the Mesha, 0th degree of Mesha, when we finish one round, we know that if the background of the sun has Mesha, then how will we see behind the sun? All that question we'll answer in the next session. But when we enter the same place, we will thereby understand that we have completed the revolution around the sun. Okay, for this I will need a good chunk of time. So I will reserve this Rashi chakra to the next session. We'll delve purely into Rashi chakra, and we have a lot of exciting things next session. We are going to do this, right? The Kundli Mandala, all this we'll do it for, for someone born at some place on earth. Thank you all for being a wonderful audience. The model of learning astronomy is a spiral model. Okay, do not worry about anything that's going overboard. Unlike math, it is not at all linear. It's not a concept to grasp. It's about observing the sky. It's about again and again looking at a few things, then looking at the Panchanga, then rethinking, re-exploring, and then a new awakening happens again and again. So it's a very spiral model of learning. Okay. So I'm going to present a few things for you, such that at the end of the course, you can go observe the Panchanga, observe the sky, and see some correlations. That's how it will be. Till then, the dots won't connect. Till then, kindly be patient. But in the next class, we'll explore further, and we'll have a lot of time for discussions.
Okay. Thank you, Ji.
Maybe end it here, Ji.
Sarve bhavantu sukhinah, sarve santu niramayaah, sarve bhadrani pashyantu, ma kaschit dukkha bhag bhavet. Om Shanti Shanti Shanti. Harihi Om. Shri Gurubhyo Namaha. Harihi Om. Thank you, everyone. Again, another wonderful session, Ji. Thank you very much. Yeah, see you.
Somebody raised a hand.
Oh, Prasad Ji.
Yeah, Namaste Ji. What's there? I mean, when we call the Jyotisha Shastra, right? We'll talk about the palm reading as well. Like, is there any session on palm reading or anything on such like that?
Our class is going to be only astronomy, Ji, no astrology.
No astrology. Okay.
Yes. We will see, Ji. We will see in the coming sessions. We'll discuss more.
Thank you all. Thank you all. Bye.
Dhanyavad.
Dhanyavad.